So as you might expect, MATLAB has some very nice functionality for working with matrices. So I know that if I say 4 times 6, I'm multiplying two scalar numbers together, and I should get 24. So this this symbol, this character represents multiplication in MATLAB, but when I've got data types that are two scalars, then it's just normal scalar multiplication. If I had imaginary numbers, 1 1 plus 1i times 1 minus 1i, then now MATLAB recognizes, oops, now MATLAB recognizes that I'm multiplying two complex numbers together, and then complex arithmetic kicks in, and I get the correct answer. So MATLAB is, the correct term is actually it's overloading this multiplication function so that it can handle multiplication of different data types. Now that you know that this is represented differently in MATLAB to this, there must be some way that MATLAB is recognizing how to do complex arithmetic as opposed to just scalar arithmetic. So now let's try and do a matrix. So I've got x. I'm going to use a function called rand, and rand just makes, well, let's use ones actually. Ones is a function in MATLAB that creates a matrix of a certain shape. So I can say 3 by 3, and the ones function generates a 3 by 3 matrix of just ones inside. So now I'll say x, and I multiply it by -6. What happens now? Now I've got a multiplication between a matrix and a scalar. Well, I know if I had to do that in mathematics, it would be the same as me saying -6 times every element inside that matrix, and that's exactly what MATLAB does as well. It takes the scalar and it multiplies it by every element in x, and since every element is 1, I get -6 everywhere. This doesn't matter, so I can write -6 times x, and it gives me the same result. I can also say -6 times x plus, I don't know, x. Okay, so now what it's doing is it's first applying the precedence of operation. So it first multiplies this term together, and I get -6, and then I add another matrix of ones everywhere. So I should get -5. Yep, I get -5. And if I say, let's say I've got y is a column vector, so it's 2, 2, 2. Notice that I'm using semicolons now because I just want to show the functionality. So I'm creating a 3 by 1 matrix, a column vector. And so I can do matrix multiplication as well. So I can say x times y. X times y works because x is a 3 by 3 matrix, y is a 3 by 1 matrix, so the result should be a 3 by 1 matrix as well. And of course it does the same thing. What if we try to do y times x? Would that work? Well, y is a 3 by 1 matrix, x is a 3 by 3, so the internal dimensions don't agree. So y is a 3 by 1 matrix, x is a 3 by 3 matrix. Do the internal dimensions agree for matrix multiplication to work? No, they don't. So what will happen if we try to do this? MATLAB will say inner matrix dimensions must agree. So it's recognizing that it can't do matrix multiplication. This is a matrix, this is a matrix. I must obey the rules of matrix multiplication. It doesn't work because y times x doesn't work. If I did y transpose x, that should work because now y transpose is 1 by 3. So 1 by 3 times 3 by 3 gives me a 1 by 3 matrix.